What is going on, guys? My name is Hussein, and I thought I'll bring back the Devtooling series where we pick a popular website and we go through DevTools and see how this website is broken up and how it's built, specifically with regards to its backend architecture. So today's website that we're going to DevTool is Twitch TV. Twitch TV is a very popular live streaming platform, and one of my favorite Twitch streamers is Lobos Jr. I've been watching him since 2012. What I wanted to do in this video is I would try to inspect how Twitch actually streams this video, or the live stream portion of it, and then I'm gonna go and look at how the chat is being queried and pulled to the client side. Let's go ahead and start. I'm gonna open beautiful DevTools here, and I'm using Chrome. By default, I always disable the cache because I want the clear experience. I don't want any other side effects as a result of the cache. I usually also use Brave for my day-to-day browsing, but I use Chrome because Brave blocks all sorts of things, tracking, and I don't want these blocked in this case because I want to see the actual experience that is designed. Let's go ahead and start. So I'm gonna refresh, clear, and refresh, and let's just take a look. Let everything loads. We're gonna go through the you can see that obviously the video is coming back, and there is an ad being played, and the chat slowly comes back. So let's just give it a few seconds until the ad completely plays. Then we're going to take a look at the entire log. All right, the video is back up. Now we can see that it is being played for a few more seconds. You can see the patterns in these requests on this left-hand side. It's very repetitive, right? We'll go through this. I think that's enough. Let's go ahead and pause recording and take a look at the waterfall. What is the first thing that we see? We see a query to using HTTP 1.1. That's the protocol they're using. Nothing wrong with that, obviously. This is to pull the page that is Lobo Jr.'s twitch.tv page, right? Using HTTPS, so it's secure. What kind of security do we have? Let's take a look. We're using TS 1.3. AS128 Gauss counter mode, and this is the key exchange algorithm curve, obviously. All right, there are many obviously secure domains because we're going to come to that. They're querying various edge servers to pull the videos from, right? These segments, as we're going to see, right? Obviously, not very interesting. There's some JavaScript, some CSS, stuff like that. And here's something interesting. GQL, what does it stand for? GraphQL. An options request to GraphQL server to make sure that, because we're in a different website, technically we're in Twitch.tv, and this guy is in GraphQL to Twitch.tv. This causes a cross-site request, which causes options, which says, okay, who can access you? I can be accessed by anybody. So technically this API, the GraphQL API, their GraphQL API, can be accessed literally from any site. So you can build your own website and use Twitch's GraphQL. Now, is it legal? I have no idea, right? But they are allowing all origins. Followed by a GraphQL. This is the post that we've seen, right? So we set an option and then say, okay, can I actually send a request to you? Yes, you can. What do we get back? We get back a JSON. What does this GraphQL have? Have a bunch of some interesting data about the stream, the signature, the values, whether this is blocked or not. So now we have a bunch of static websites. I guess this is a font. You don't get a font. Just some JavaScript, and here's the interesting part. Let's go through this first. You see there's a request to upgrade an existing connection to WebSockets. And there are two WebSockets connections. One is called V1, going to pubsub-edge twitch.tv/V1. So there is a pubsub edge server that is very close to me. I'm in California, so probably the domain resolves to an IP near me in California. And that gives me a beautiful WebSocket connection. And they have two. One for the chat and one for actually the commands. When I looked at it, when I look at this messages, look at this. Let's go through the first one here. This guy this chat messages, the first request chat message was ping, and the server responded with pong, right? You have to send this message so the server can recognize you, and the server immediately will say, okay, what do you want to do? The client says, I want to listen, and there's a nuance here, some sort of authentication, I believe. And then topics. I want to listen to ads. I want to listen to video playbacks. I want to listen to watch parties, stream chat room. And you can copy these and actually try to establish a WebSocket connection, and it will start giving you back results. But what I notice is it eventually stabilizes into the view count. It will give you back how many viewers does Lobos currently have. So we have 1,389, and then a few moments later we get 1,400 viewers, and so on. So this is just dedicated to update the subscribers and viewers. So these are the commands WebSocket. This is a very common pattern where we have two WebSocket connection, one for system commands, to update the chat, headers to update the subscriber views, and the other one is actually the messages. And we've seen this in Discord when I talked about Discord. I'm going to reference the video here if you're interested. It's always the audio channel WebSocket is different than the system commands WebSocket. You don't want to have congestion control, like you want one to have more priority over the other. It's okay if the chat lags, but the system commands should continue. So these are actual text messages, right? The chats, and let's go through them. Hopefully I can scroll here, and you can see this is no invert, this guy, first message 0. There's a bunch of properties here, but room ID, which room you're on, subscriber equal 1. This is interesting. I believe this means that is this guy a subscriber or not, right? And the user ID, user type, and the private message. Are you team Dark Sword or team Twin Dragons? So this is the actual message, and I don't know if we can catch that message or not. There you get the message. That's the message that they sent. And obviously they have much more details here. And we can say is a 1 month subscriber, right? We've seen this in the metadata, right? Okay, this is the chat effectively. And you can basically, guys, take this and establish a WebSocket connection, right? Like this. But yeah, guys, if you actually try to connect manually to these WebSocket servers, like you can essentially establish a connection, like they say webs equal new WebSocket, and then just provide the URL, and then you can wire the event on message equal a console.log. So if you receive a message, just print it, and then you can do webs dot send. We're gonna send JSON.stringify. So if I stole this webs, I'm sending a ping because that's what they were expecting. You see that immediately we get back a response, right, from the server. This response says dun, 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 pong. So it does actually respond, and if you can ask for a request to listen on certain things. So let's try this. Let's try listening on video playback. So we're gonna send this request, and this is what they're expecting, listening on a certain comment. Oh, they closed the connection. Yeah, they're gonna close the connection if you wait too long, but you get the idea, right? So you can do that. You can try again, and let's do send. You can immediately see that, hey, we got a response. There is a response. There is an error response, but I believe, but you can see we're receiving actual data. This is the message. We said what? The viewer count, right? You get the viewer count, but I can see I get another message like I'm hooked to this connection. I'm gonna get updated with the viewers, number of viewers all the time. So look at that. As you can see, guys, my connection is not closed, and I'm getting quite cool update of the number of viewers by just writing these 3 commands. So yeah, to summarize, for the WebSockets, for the chatting, they have two WebSocket connections. One is for the system messages, number of viewers, and you can see that a lot of them are actually failing. And my guess is because I'm not logged in. If I log in, my guess is I'm gonna get more messages, more system messages when I'm logged in. And the other WebSocket is for actual raw chat, right? And you can see that we're ping-ponging to send a request to the server that, hey, I'm still alive. Because my guess is if Twitch didn't receive a message for X amount of seconds, it's going to close the connection. All right, let's continue. I'm going to go through this. This is the WebSockets. We're seeing another request for GraphQL, a pre-flight for options, and then followed by these requests. And I wonder if there's a way to kind of disable these course options, I mean, it's the same domain, right? I believe there is like a public list of URLs that allow you to kind of join these websites, so the browser doesn't make a flight request, because these are expensive, right? For every query you make a flight, and you're gonna see a flood of them, really. But effectively, this is just more metadata that we're receiving. What are we receiving? Is denied underage. Yeah, so this is to prevent like underage streaming and show you like different, maybe disable the chat, because we know that YouTube, for example, disables the chat if the person who's streaming or making the videos is an underage. Privacy low, raw, I don't know what that means. A lot of just metadata, useful metadata for Twitch. And yeah, some more data metadata, not important for us. Let's continue. JavaScript and another GraphQL query, probably game. Oh, that's interesting. It tells you, okay, which game Lobo's playing, and we know he's playing King's Field 2, right? It's from his title, but that's interesting. Some more metadata. It's like, okay, what is this about? You get the idea. Done with GraphQLs. And then we can see this interesting thing. There is this like a gear icon, and there is this Amazon IVS WASM worker. So this is a WebAssembly worker. Which language did they compile this assembly with? I don't know, but apparently they are using this WebAssembly. And it is holding the static Twitch CDN. Okay? So, there's a lot of caching going on, apparently. And then more data, more information, some CSS, some scripts. This is probably to enable the WebSocket connections. Then we're going to see a lot of images downloaded. And here's the thing. I think these images are being downloaded through H2, right? HTTP2. And they're cached so that when a lot of the same person, makes another chat, the browser will not make a request to fetch that image again, despite that will obviously give you a 304, not modified. But Twitch is smart in a way that once they download the message once, they never make a request in the same session, because they build a blob object, and I showed how to do this in one of my videos, and then they just render an image out of this blob effectively without making a request to prefetch the image. Pretty neat. Like, these small things adds up, guys. And then let's continue. I'm gonna scroll into the video part, to the interesting part, and here it is. Oh man. All right, so it looks like we waited a long time and the request content was evicted from inspector cache. Yeah, damn it. Okay, no problem. We're gonna record again, and then we're gonna refresh the page. Right? Let's do it fresh. This time we're gonna actually record the content for the video. So let it rip, and let's take a look. So you can see there is a request to the Weaver, right? I want to take a look at this. There you go. This is what I want to look at. So there is a request to a domain called Video Weaver, and that request have some metadata about what URLs the client need to pull to fetch the videos. And this is very interesting. This is for effectively, I believe, right? So the different segments, right, that you can download. We're going to see how long each segment of the video is. But this is, you're going to see this occurring, the date range. This is a catalog of the URLs that you need to download, because the client doesn't know which site to connect to, right? And these URLs might change. This is effectively client-side load balancing, in a sense, if you think about it. So you get a bunch of URLs, and immediately after this request, you're going to see the request to actually pull these URLs. Did we get evicted again? No, this is the pre-flight, right? So this is a request. Can I actually make a request to you? It's just dumb, this whole course thing, right? And then make the request, and here's the content. So now if you double click this thing, actually you can download it. And
Oh my God.
did you hear that? Actually listen to that. I muted the stream, but when I downloaded that, have you seen? It's actually exactly 2 seconds.
Oh my God.
Look at this. It's 2 seconds, and you're gonna see this goes in. It's very, very repetitive. You're gonna see this is a 2 second request, and then we're gonna do it again and again and again and again. Right? This is how HTTP live streaming. This is using the Apple standard protocol. We've seen this with YouTube. This is exactly identical to YouTube, right? And everything you download, like this is another segment, by the way. If you play this segment, that's another 2 second segment. So it's Twitch downloads 2 second segments every time, but you can see that these segments get downloaded every time you double click. You can see these segments. See, it's always 2 seconds. This is the decision they made. They download 2 second segments at a time. And who told you what segment URL? Let's take a look at the URL, by the way. Look at this. Boom. Look at this speed. Hopefully there's no information about my information or anything I do here. Doesn't look like it, but look at that. This is the segment URL. This is a huge URL. TS, I thought it was TypeScript, but it has nothing to do with TypeScript. I believe TS is the streaming extension for Apple TV streaming. But this is, look at this. This is very interesting. Each segment is uniquely identified. This is a huge URL, right? Which has this segment, and this is one, right? One URL. This obviously changed based on the edge, right? Video edge, like where are you, right? Hey, look at it, LAX. So is that LA, right? Because that's the closest thing, I guess, maybe. This is how Twitch breaks down their streaming. Everything is uniquely identified per a 2 second segment and replicated everywhere, right? So the caching is so powerful here at this stage, and they made it 2 seconds so that the caching can be copied everywhere. So every client, whether me or you, if I request to pull this segment, immediately you know which segment to pull. It's a 2 second segment. And notice that there has nothing to do with the actual streamer. Who am I watching? I can change one letter here and I get a 2 second stream of a completely different streamer, right? It's a very interesting architecture, if you ask me, right? They kind of identify the segments by ID, and they don't care, right? Now the question about security is like, what if the stream is private? Can you have private streams in Twitch that only subscribers watch or something like that? If that, then the CDN has to do some sort of a authentication. Can you view this segment or not? But yeah, this is what I wanted to talk about, guys. And they're using HTTP 1.1 on purpose here. And here's what I'm not sure about. If I show the initiator, you can see the initiator is, who's the initiator? The initiator is this WASM thing. And my guess is the protocol being displayed here says HTTP 1.1. I believe this is the communication between the browser and the WASM web worker. The web worker and the actual server has a completely different worker that is not visible to us here. And I really want to know what are the communication on the back end. Back end meaning whatever in front of the WASM web worker here, because yeah, of course it's gonna be HTTP 1.1 because it's just a local connection. It's a local host connection almost, right? I doubt that it's all even secure. This thing doesn't have to be secure, right? Because it's a local thing, right? But yeah, it is very interesting to see all these things. I'm not very familiar with web workers and how they work, but I know they are effectively a proxy that they are sitting with the browser, and you make these requests to this web worker, and the web worker, everything goes through it, and a way will make the request on your behalf. So there's a lot of requests that we don't see here, right? Going from the web worker to the actual server. But yeah, effectively, this is how simple this thing is. And when you actually look at the HTML front end, this is just the video tag, the video URL. This does all this work behind the scenes. It's always good to understand how this actually is built so that you can understand how things work effectively without working with just normal black boxes. All right, guys, I'm going to leave it at that, and I'm going to see you in the next one. Take care. Goodbye.